Okay, welcome back. So we just got done learning about how to multiply variables and numbers with exponents and how to use the exponent rules associated with multiplication. But what happens, let's say, in a case where maybe I have 2 to the second power, but that number, that power, this power right here, happens to be raised to another power. Well, let's leave this guy alone for right now, and let's go back to some variables. If I have x squared and I raise that to the third power, well, order of operations says to do exponents first. Well, parentheses. I can't do anything else inside of here. I can't do this exponent, but perhaps I can do something with this guy right here. This right here, being raised to the third power, simply means, in expanded notation, that I have x squared times itself 3 times. X squared times x squared times x squared. Okay, that makes sense so far. So now how do I figure this out? Well, we just got done talking about what do we do with exponents when we multiply. Well, I add the exponents. Same base, 2 plus 2 plus 2 is 6. Okay, well that makes sense, but there's got to be an easier way. How do I get between these two numbers here? What's the relationship between 2 and 3 that gives me 6? Well, a very, very long time ago, when you first learned multiplication, you might have been taught that if I have 2 plus 2 plus 2, that's the same as saying 3 times 2. Right? I have 3 2's, and when they're all added together, that's the same as 3 times 2, or 2 3 times. So this relationship then simply is that I multiply, thinking ahead, multiply the exponents. So, same here. I could simplify that, and that's probably the easier thing to do. But let's go ahead and do this exponentially. I'm going to have 2 to the 2 times 3. 2 to the 6th. Then I can put that in the calculator pretty easily. And, gosh, I don't even know what I get. Let's see. 2. And if I can, especially if I have a calculator handy, simplify 2 to the 6th gives me 64. So what's our new rule going to look like? Well, a, being consistent with our base, a to the n, some exponent, raised to the power of m, is a to the n times m. When I raise a power to another power, I multiply the exponents. Keep the same base. Let's do an example. Let's do another example. I've already done a couple. How about negative x, let's throw a little curveball in there, to the third power. Let me clean that up. negative x to the third raised to the fourth. Okay, no reason to panic. Just because I have a negative in there, notice this guy is inside the parentheses, so I have 3, or negative x to the third power raised to the fourth power. So if I follow my rule here, the base stays the same, which is negative x, and I take the two exponents and multiply. 3 times 4, which is, don't forget your negative, negative x to the 12th. And since x is a variable, I can't simplify any further. I have negative x to the 12th. Okay, so why don't you try one now, real quick. We'll try one and then I'll throw another little curveball at you. Why don't you try negative 3, and let's clean that up. Tell you what, no curveballs right now. Let's just do y to the fourth raised to the third power. Go ahead and stop the video, give this a try, and see what you come up with. Okay, base stays the same, so I have y as my base. I'm going to take the two exponents and I'm going to multiply them. 4 times 3, so it's y to the 12th. So far so good? Alright, let's try a different one. A little bit of a curveball here. Let's try it with a negative exponent, see what happens. What if I have 3y? Back up going. Back up. Let's not go there yet. What if I have just y to the fourth times to the negative 2 power? Okay, well, no panic. Same rule applies even though it's a negative exponent. Keep the same base and you simply multiply 4 times negative 2 for the exponent. Now, when this happens, students tend to want to stop here, but remember, we don't want to see negative exponents in our answer. So then I have to go back to my negative exponent rule, which says that if there's a negative exponent, the variable and the exponent go downstairs and the exponent goes positive. Final answer. Good. Better. Okay. One more curveball, and then I'll let you go. Now let's say, and this is where this gets a little bit tricky. Now let's say I have 3, let's just use x squared to the third power. Okay. People get a little weird here because now I have a coefficient other than 1. And when I have coefficients, I've got to remember, this goes back to the exponent of 1 rule, that any number always has, number or variable always has an exponent. If it's not written, there's always a little 1 there, because anything to the first power is just itself. So this 1 is kind of understood. So what I have to do, it's almost like distributive property. When I multiply, I'm going to distribute that exponent of 3 to both of those exponents. So what I really get is 3 to the 1 times 3 times x to the 2 times 3. 1 times 3, I distribute there, 2 times 3. Okay, simplify it. 3 to the third and x to the 6th. Alright? Now if you got that far, great. Probably should go one step further. I can simplify the number with the exponent. 3 to the third is what, 27? 3 times 3 is 9, times 3 is 27. And x to the 6 can't be reduced anymore. There we go. So, give your entrance ticket a shot on some of these. I didn't have a practice on this one. There is one on your entrance ticket. Refer to this problem if you're having difficulty, and I'll see you tomorrow.